Consider one more example from Maxima and Minima. Let volume of closed circular cylinder is given. Then show that its height is equal to the diameter when area is least. First of all, let us understand the example properly. What is given to us? Volume of closed circular cylinder is given. It is general example. This will give us some formula that we can use for CET and JEE. Okay, no numbers are given there. General example is given. So consider it carefully. Volume of closed circular cylinder is given, means volume is fixed, it will not change. Volume will not change, volume is fixed, remember. Then show that its height is equal to its diameter. When area is least, means minimum area will give us height is equal to diameter. Minimum area, for minimum area we will have the relation height is equal to diameter, and that is what we have to show. Okay, so let us consider this example. There are two formulae we have to use in this example. First of all, volume of the cylinder, and second one is area of the cylinder. Volume of the cylinder and area of the cylinder. Remember, cylinder is closed, cylinder is there. Cylinder is closed. So we have to consider total area of that cylinder. Okay, so let us consider the given things. Volume of the cylinder is given. And let height and radius of that cylinder are h and r. We will consider let h be the height, and r be the radius of this cylinder, Now consider volume. What is volume of this cylinder? What is the formula? Therefore V is equal to volume. V is equal to, yes, pi r square into height of that cylinder. So pi r square is the area of the base circle into height, that is nothing but volume of that cylinder. It is pi r square h. Now look here, V is given, it is constant. What are changing things? R and h. Means two variables are there. And we are solving the examples with differentiation. So there must be single variable. So we will convert this either h into r in terms of r, or we will convert this r in terms of h. कोणता तरी एक आपल्याला कन्वर्ट करावा लागेल. Okay, so let us convert it. So let h is equal to, I will convert this h in terms of r. I will convert this h in terms of r. You may convert r in terms of h also. कोणताही कन्वर्ट केला तरी चालेल, पण जो शिल्लक राहील व्हेरिएबल, with respect to that variable you have to consider your differentiation. Okay, so here h in terms of r, it will be h is equal to v upon pi r square. H is equal to v upon pi r square. This is value of h. Okay, now consider area. Area should be least. Minimum area means that will be our function. What is minimum? You have to ask question to that question. What is minimum or what is maximum? And that should be your function. So what is the minimum here? Area is minimum. So area will be my function. I will consider that area. Now area of the cylinder. Area of that cylinder is, what is the formula for area of the cylinder? Is area, S is equal to, I have to consider total surface area. S is equal to, for cylinder, remember, total surface area means base circle, top circle and curved surface area. Which is along the height of the cylinder. Okay, so total how many surfaces are there? First of all, curved surface area, we may consider this cylinder. This is also a cylinder. This is base, one circle. This is top surface. This is another circle. And this is curved surface area along this height. So 2 times pi r square, 2 times pi r square of the base, pi r square of the top, and into curved surface area. This curved surface area is nothing but rings put one another each. एकावर एक rings ठेवलेले आहेत बघा. So what is a ring? Having its length, it is 2 pi r. अशा किती rings ठेवल्यात एकावर एक? There are h number of rings. Height of the cylinder is h. So h number of rings are there. So what is curved surface area? Is nothing but 2 pi r into h. Okay, so this total surface area is curved surface area 2 pi r h plus top plus bottom 2 times pi r square. This is nothing but total surface area of the cylinder. Now I will consider this h in terms of r, because again there are two variables in my function. So whenever I have to differentiate this s with respect to, I will differentiate it with respect to either h or r. So I will convert this h into r, so that this total function will be the function of r only. Okay, so write this. This is equal to 2 pi r h. What is h? H is equal to v upon this pi r square plus this 2 pi r square. Now this pi will get cancelled. R upon r square, that is 2 times v upon r. V upon r. Pi r gets cancelled plus 2 pi r square. This is our function s. Now total this function is in r. Remember this v is given, it is constant, it will not change. Volume will not change. We have to find least surface area. So s is equal to this one, and this function is in terms of r only. V is now constant, remember. V is constant. So differentiate this with respect to r. Differentiate this function s with respect to r. Differentiate with respect to r. So what will happen? ds by dr. ds by dr. Or you may consider this as f of r. This function can also be considered as f of r, because it is function of r. Okay, so first order derivative. This 2v is constant. 2 times v, it is constant. 1 upon r. What is the derivative of 1 upon r with respect to r? It is minus 1 upon r square plus 2 pi r square. 2 pi r square. So 2 pi is constant, and the derivative of r square with respect to r is 2r. So what is ds upon dr is equal to minus 2v upon r square plus 4 times pi r. You may mention here v is constant. V is constant. V is constant. Okay, this is first order derivative. Then second order derivative, again differentiate with respect to r. Again differentiate this with respect to r. So what will you get? d2s by dr square, or if you consider it is f of r, then this is f dash of r, and this will be f double dash of r. Okay, so second order derivative is equal to, already here it is a minus 2 times v into derivative of 1 upon r square. Derivative of 1 upon r square means we have to find d by dr out. 1 upon r square means r raised to minus 2. So using that formula, x raised to n with respect to x is n into x raised to n minus 1. So this will become minus 2 into r raised to minus 2 minus 1, that is minus 3. And r raised to minus 3 means 1 upon r cube. So this is minus 2 upon r cube. So put this value minus 2 upon r cube. Here derivative of 1 upon r square. So minus minus, it will be plus, or we will write this as it is and then we will multiply upon r cube. Next, plus this one 4 times pi into derivative of r with respect to r, it is 1. So 4 pi as it is, and hence this is equal to minus minus plus 2 into 2, it is 4 times v upon r cube plus 4 pi. Now if you look at this, v is constant, it is volume, so it will be always positive. This term is positive, and r cube, r is radius will also positive. So this total will be always greater than 0. So whatever we get the value of r here, by taking ds by dr is equal to 0, that will give me the minimum surface area. Why? Because second order derivative is greater than 0. But then also we will go through our process. Now for turning point, or for minimum surface area, yes, ds by dr, that is first order derivative, which we call as f dash of x. Here it is f dash of r, or ds by dr. So ds by dr is equal to, what is the value of ds by dr? Minus 2v upon r square plus 4 pi r is equal to 0. This value will be 0. Now solving this, I will get, therefore 4 pi r is equal to 2v upon r square. 4 pi r is equal to 2v upon r square, and therefore take this r square here, you will get 4 pi r cube is equal to 2 times v. Here 4 pi r cube, this r square is multiplied, is equal to 2 times v. Here v is equal to, divided by 2, it will be 2 pi r cube. I will put this value of v here for d2s by dr square. So for this value of v or r is my variable, consider this one. Therefore this one r cube is equal to, or write from this step, can also you write 2v upon 4 pi, that is equals to v upon 2 pi. Value of r cube is v upon 2 pi. Substitute this value in second order derivative. Therefore d2s by dr square is equal to 4 times v, 4 times v upon r cube. What is r cube? R cube is obtained here. This value of r cube is there. R cube is equal to v upon 2 pi. This 2 pi will multiply at the numerator, plus 4 pi. So this is equal to v will get cancelled. 4 into 2, 8 pi plus 4 pi, which is equals to 12 pi, and which is greater than 0. Since our second order derivative is greater than 0, the function will be minimum. Therefore the function s will be minimum when this r cube is equal to v upon 2 pi. Keep it as it is, or you may calculate this r is equal to cube root of this one. Okay, but I will keep this as it is. R cube is equal to v upon 2 pi. At that time s will be minimum. And how we can say this? This is by second order derivative. Since by second order derivative test. Okay. Now this will be minimum. Now what is my question? What I have to find? What I have to show? I have to show that this height is equal to the diameter, means h is equal to 2 times r, that I have to show. Okay, now consider this value of r cube is equal to v upon 2 pi when the surface area is minimum. So what is the relation between h and r? I don't have to find the value of s. I just have to show that height is equal to diameter. Height is equal to diameter. So what was that relation between h and r? काय रिलेशन मिळालं होतं आपल्याला h आणि r मध्ये बघा बरं. What was the relation between h and r? What was the relation between h and r? V is equal to pi r square h, right? So h is equal to v upon pi r square, right? So now h is equal to v upon pi r square. H is equal to v upon pi r square. So put this value of r square. Put this value of r square using this value of r square here. You will get the relation between h and r. You will get the relation between h and r. Yes. Now h is equal to v upon pi r square. Look at this. R cube is equal to v upon 2 pi. I will put this v is equal to 2 pi r cube. V is equal to 2 pi r cube in this relation because I want h in terms of r. Diameter means what? 2 times r. Diameter means what? 2 times r. So what will you get here? This is equal to using this one. Yes, v is equal to 2 pi into r cube. V is equal to 2 pi into r cube. Put this value 2 pi r cube upon this pi r square. This pi will get cancelled. R cube upon r square will get cancelled, and therefore h is equal to, there remains 2 times r, and this 2 times r is nothing but diameter of the cylinder. Hence h is equal to d, means height of the cylinder is equal to diameter of that cylinder when area is least. When area is least. Got it? This is the important example. Remember this relation. When you are given that volume is fixed, volume is given and area is minimum, at that time for that cylinder, remember h is equal to diameter of the cylinder, 2 times radius of the cylinder. तुम्हाला जर कोणी गावाकडे असा प्रश्न विचारला, शेतात एक पाण्यासाठी टँक तयार करायचा आहे ना, सरफेस एरिया कमीत कमी पाहिजे का, कारण त्याला प्लास्टर करावं लागणार आहे, बाकीचं काम करावं लागणार आहे. सो त्यासाठी काय करायचं आहे आपल्याला, व्हॉल्यूम गिवन एवढ्या व्हॉल्यूमचाच टँक पाहिजे पण सरफेस एरिया कमीत कमी पाहिजे. सो काय सांगणार तुम्ही, कन्सिडर द सिलेंडर सच दॅट height of the cylinder is equal to diameter of the cylinder. Okay.